And now we've got a tricky example. It looks deceptively simple, but you need to be careful here that you don't try and solve it by just multiplying both sides by x minus 4, because we don't ever want to multiply our unknown by 0 or divide an equation by our unknown because we lose solutions. Instead, what we want to do is we want to graph the left-hand side, and then we want to graph the right-hand side and see when this function is greater than the line y equals 0, or the x-axis. Alright, so graphing this, there's going to be some key points. One thing I like to think through when I've got a fraction is to think about, well, what will happen when the top of this fraction is 0? Well, how do I make it be 0? I know 1 minus 1 is 0. So I'm thinking here, and I just literally write down my thoughts. When x is 1, I'm going to have 0 divided by negative 3. It doesn't matter what you're dividing 0 by, the answer will be 0. So that gives me 1 point on my graph straight away to think about. Now, I can't make the bottom of a fraction be 0. So that means that x cannot be 4. Because if it is, I've got 4 minus 4, and that will give me 0 on the bottom of a fraction. Won't work. Okay, now we haven't graphed a lot of these before, so if you look at this and think, I don't even know what shape it is, don't worry, because we'll get onto this in future topics. And we'll have a look at how you can find an asymptote on the y-axis as well. So we can see that there's going to be an asymptote at x equals 4, and if you like, as you figure things out, you can start plotting them. You can say, well, let's this be 4, and x can't go there, and when x is 1, let's say this is 2, that would be 1, y equals 0. So I know it goes through this point and it can't go here. That's something. Now, you might also know that graphs of this sort of form with a number of x look like a hyperbola. So seeing that we've got something similar might give you a clue that we're going to have some asymptotes and some shapes like this. Now, if we think through what y can't be, think about what would happen if y was 1. And again, we'll look at how to figure this out again in future topics. If y was 1, then when I went to solve this and I said 1 was equal to this, can that happen? Can this divided by this be equal to 1? Well, no. Anything divided by itself is equal to 1. And how can these be the same when we've taken the same number and subtracted a different number from it? They won't be the same. So this sort of thinking is what we'll be getting to later. But I can spot that y can't actually be 1. Okay, so I've got an asymptote going along here, and y can't be 1. Now I've got my 0, and I've got a discontinuity. Next thing to do is to make my table of values. And I'm going to make it with the 3 lines in it. Now I want to investigate this point, x equals 1, and x equals 4, because something interesting happens at both of those, and I want to look at a point on each side. So it makes sense to look at 0 because that's smaller, 2 or 3 because that's in between, and something bigger. Alright, if I sub 0 in for x, I've got negative 1 over negative 4, and that just gives me a quarter. That's a positive number. If I sub in 1 for x, I've got 1 minus 1, I've got 0. So that's 0. If I sub in 2, I've got 2 minus 1, so I've got 1 over negative 2, so I've got minus a half. That's a negative number. Subbing in 4 gives me 4 on the bottom. That can't work, so I'm just going to put like a little asterisk here to show that that's something that's not going to happen. It's not going to have a sign, is it? And subbing in 5, well, I'll have 1 on the bottom, 4 on the top, so it'll be 4 over 1, which is 4, and that's positive. So I've got a bit of a clue here that from here, it goes positive. Okay, but it can't get past this asymptote, so it's probably going to come up something like this. And as it approaches this point that it can't reach, it's going negative. So it's probably going to go down something like that. And then after the asymptote, it's going to be positive. Well, if there's 2 asymptotes here, chances are it's doing something like that. Now, my point is, it's not going to change from positive to negative, and what I'm looking for is when it crosses the x-axis. Because I want to know when this graph is bigger than 0. So it looks like it's bigger than 0 all the way out here. So that whole section. And we don't want to include when it is 0, so that will not be included at that point. And it's also greater than 0 everywhere out here. So I've got 2 parts to my answer. I've got x less than 1, or x greater than 4. And I can write that as a union of two sets. If x is less than 1, but not including 1, I've got curly brackets with negative infinity, comma 1. And here again, sorry, not curly, but round brackets, from 4 stretching all the way to infinity.